right, we talked before about finding the area between two curves. We said that what we needed to do to find the intersection points was to set them equal to each other. Minus x squared minus 10x equals negative x squared plus 2x. And that we would solve and try to find what my intersection points were, what my x values were. So bring everything onto this side, so 3x cubed, I would end up, the x squareds will cancel out. I'll have a minus 12x equals 0. See if I can back this. Pull out a 3x, I'm left with x squared minus 4, which means I get 3x times x minus 2, x plus 2 equaling 0. So that means that my x values are 0, 2, and negative 2. Well, hang on a minute, because that means that we would have 3 intersection points. We've only dealt with 2. Well, yeah, look what happens in this graph. It intersects at 3 different points. That means that if I want to find the area under the curve, well, I have this area right here, which I'm going to make here in white. That's one area under the curve. But then I'm also going to have this other area under the curve that I'm going to draw here in purple. So what gives? Well, that means we're just going to have to make 2 separate integrals. So for the part in white, what numbers do those go from? That goes from this intersection to this one. That's going to be the integral from negative 2 to 0. Now, what's my top function? Looking at the graph, it's going to be the cubic. But how can I tell that for sure without aid of the graph? I can just plug in, for example, negative 1, and I would find that the cubic, f of x, is actually the bigger one. So I do the top, and then subtract the bottom. So minus negative x squared means plus an x squared, and then minus a 2x. So that's to find that portion. Now I also have the second integral, so I'm going to have to add here in the middle, and I'm going to do this other integral, which will go from 0 to positive 2. Now in this case, what's on top is going to be the quadratic, so negative x squared plus 2x, and then subtract the top, so minus 3x cubed plus x squared plus 10x dx. Now what I can do is take the integrals immediately, or I can try to simplify a little bit first. That's what I'm going to do personally. I'm going to simplify this a little bit. When I do that, I can say that the x squareds are going to cancel out actually in both of these equations. And I'm going to end up with a negative 12x down here and a positive 12x on this one when I do my integral. So that means now I have the integral from negative 2 to 0 of 3x cubed minus 12x dx. And then over here, I have still the integral from 0 to 2 of a negative 3x cubed plus 12x dx. Now let's take these antiderivatives and see what I get. I would end up with 3 over 4 x to the 4th minus 6x squared. That has to be evaluated from negative 2 to 0. Well, when I plug in 0 first over here, I'm going to get 0. When I plug in negative 2, I'm going to end up with a big number. I'm going to have positive 16. I can divide that by 4, though, to get me back to 4. So I'm going to have 12. And then minus, if I plug in 2 times 2 is 4, positive 4 times 16. So minus there. So I have 0 minus a negative 12. So 0 minus a negative 12, which gives me a positive 12 for that first part. I'm going to need to add it with whatever I get for the second part. So when I do this antiderivative, what I'm going to get is a very similar looking expression. Negative 3/4 x to the 4th plus 6x squared. Again, evaluated this time now from 2 to 0. When I plug in the top number 2, I'm going to get, again, 16, which divided by 4 is 4, times negative 3 gives me negative 12. And what I need to do from there is to, excuse me, I need to add, subtract when I plug in 0. And when I plug in 0, I get 0. So I should get negative 12 for this. Well, I hope I would finish this problem off right. When I plug in 2, I get negative 12 here. I've got to plug in 2 for this. So negative 12 plus 2 squared is 4 times 6 is 24. So that means that I should get here 12 and then subtract my 0, so I get positive 12 again. So I have 12 plus 12. That means that my final answer then is adding those up, which is 24, and I guess I should say units squared because we're looking for area. So there you have it. When you have three intercept points, just the main thing is try to be as organized as you can and see if you can find where the intersection points are, and make sure you pay attention to what's on top, what's on bottom. Just so you can see, for example, here's one more. I just want to set this interval up. If I set up x to the fourth minus 2x squared equals 2x squared, that means I'll have x to the fourth minus 4x squared equals 0. Pull out an x squared. I'm still left with x squared minus 4. So x squared, x minus 2, x plus 2. So that means x will equal 0, 2, and negative 2 again. Now here's the thing to look at for this problem. Again, we want to find out what's on top and what's on bottom. The top function in this case, let's plug in, for example, from 0 to 2, let's plug in a positive 1. By plugging positive 1, what's bigger? 1 minus 2 or 2? That's negative 1, that's 2. This is bigger. So from 0 to 2, g of x is on top. Now if I go from negative 2 to 0, now tell me what's on top. If I plug in, say, example, negative 1. Well, negative 1, I get the same thing up here, and on the square, I get the same thing down here. So I get negative 1 and 2. So g is still on top. So in this case, I need to do the integral from negative 2 to 0, and it will be g minus f, and also the integral from 0 to 2, and again do g minus f. Now, in most cases, you can combine this to make it negative 2 to positive 2. Sometimes this separation point could end up being too much. If there's a discontinuity or something, it could really mess things up. So be careful. I would suggest to play it safe and just leave it separate like that. If you follow through this, if you want to see if you can figure out this answer, you should get both individual ones become 64 over 15. So your final answer is adding those two together, you should get 128 over 15. And yes, fractions are very much acceptable.